Okay, hi everyone. First, I'd like to thank Raquel and Tim for inviting me for this webinar and for Raquel for organizing this. I'm very glad to be here to present research I conducted in Ohio from 2014 through 2016, which investigated specific cultural practices aimed to recover severely cold-injured Vitis vinifera grapevines. This will address exactly how to recover a severely cold damaged vineyard by explaining the most efficient practices in vineyard rehabilitation. This presentation will give you the knowledge and pros and cons of various pruning and training systems when recovering a damaged vineyard and ultimately save you time and money. So let's begin with an outline of this presentation. We'll start with cold hardiness of grapevines. We'll go through the overview of the freeze damage in Ohio and many other places in Northeast America. We'll look at the goals and objectives of this research and examine two studies, one focused on cane quality and the other on training systems for trunk renewal and recovery. And then we'll end up with some conclusions and recommendations. So this table shows cold hardiness classes. On the far left column ranges from very tender to very hardy. The next column is the corresponding range of lethal temperatures that result in 50% primary bud damage, also known as LT50. And you can see vinifera species are typically less cold hardy than hybrid and labrusca types. So in 2014, extremely cold air moved from the polar regions into Ohio, and in the 2014 polar vortex resulted in statewide minimum temperatures between -4 and -31 and -24 degrees Fahrenheit. Highlighted in red are areas of the most grape acreage and production in Ohio, and you can see in those areas it got very cold as well. So we measured primary bud damage of 23 Vitis vinifera varieties and 13 hybrid varieties. We found vinifera sustained 100% primary bud damage when exposed to -11.3 degrees Fahrenheit. A survey was conducted in 2014 by Damian Lewis, which showed American varieties sustained 30% primary bud damage, hybrid 60, and vinifera nearly 100%. And this resulted in an estimated vine and wine loss of about $12 million. So this photo shows a typical commercial vineyard at that time. This is Cabernet Sauvignon vineyard. You can see this is completely damaged all the way to the ground. And then in the foreground is a Traminette, which is a hybrid variety. And there was reduced crop on the Traminette. However, there wasn't significant trunk damage. So they were able to save those vines and actually harvest a crop from them that year. So commercial growers of cold tender Vitis vinifera were faced with questions on how to rehabilitate their vineyard because there was a lack of published research on optimum vine recovery. So unfortunately, there was back-to-back years of extreme low temperatures, even lower in 2015 than in 2014. In February, temperatures ranged from -5 to -33 degrees Fahrenheit. Again, areas of high grape production in red got very cold. So I just want to kind of repeat this story here of back-to-back winter injury. In 2014, growers encountered vine dieback and began to train new growth. Then the new growth was damaged again with similar vine dieback. However, before the 2015 winter damage occurred, growers had mounded soil on top of the trunk base, which acts as protective insulation to the trunk base. And when this mound was removed, indicated here in this bottom right photo, there was live bud and cane tissue near the trunk base here in spring of 2015. And it is from this growth that material in the following studies originated. So our goal was to provide information on how to mitigate freezing damage. And we did this using two objectives: to determine the best cane size and the best training system to use following severe cold damage in cold-sensitive cultivars. So let's start with study number one. We wanted to look at cane morphology of Cabernet Franc, and we wanted to see what is the best type of cane to mitigate or prevent freezing damage. So the top left photo is an example of Cabernet Franc vine dieback with complete damage to the buds, the canes, the cordon, and then the trunk as well. And the only living tissue was at the trunk base that was protected by the soil mound the year before. And we can see the new growth is only originating from that protective area. And that's in the spring. In the summer, those shoots continued to grow and we trained them into a fan shape. And we wanted to train them into a fan shape to reduce any sort of shoot self-shading. We didn't want to bundle these shoots. That can cause shading and disease problems. And we also wanted to retain all of the shoots to devigorate the vine. So in fall, here are the mature shoots or canes of two cane sizes. We have N, which indicates normal cane size. Large is tagged in red here. And then we also have tagged in yellow very small cane sizes. But we're just, for the purposes of this discussion, we'll just look at the normal and large sizes. And if you can't tell the difference from this photo, on the bottom right is an example of a normal cane with a 7 to 9 millimeter diameter, and a large cane, which was basically around 12 millimeters or greater in diameter. So before we talk about cane morphology, it's important to understand what a large or bull cane is so you can spot them in the vineyard. They typically have the following characteristics. They have rapid and vigorous growth, long and large internode diameters and internode lengths. They have somewhat flattened shape, and relative to normal sized canes, they're poorly fruitful. So we collected data on normal and large shoots, which included shoot length, lateral shoot length, internode diameter, leaf area, and pruning weight. We tested freezing tolerance of buds and canes of normal and large diameter canes using the oxidative tissue browning method. So we sampled canes and we cut them into these 2 bud cane sections of both cane sizes. We then wrapped them in cheesecloth and then encased them in foil. And then we connected a thermocouple to the surface of the cane to measure the surface cane air temperature. And then we placed them into the environmental freezer where the temperature decreased about 4 degrees Celsius per hour to mimic the environment. And then we removed casings at different times at different target temperatures to see at what temperature damage occurred. So bud tissue assessment was conducted using a razor and cutting a cross-section to expose the bud tissue for visual assessment. The top left photo shows live, healthy green buds, and the top right shows a damaged primary bud. The bottom pictures are examples of phloem. So here's a live phloem. It goes straight from the bark right to this nice green color. And then with phloem injury, it goes from the bark into this brownish phloem color. That's due to the contents of the phloem cells releasing due to cold damage. That's phloem injury. It's similar to what happens when you cut an apple and it turns brown after a few minutes. And it was from this bud and cane tissue assessment we were able to calculate LT50s. So we also looked at carbohydrate concentration in the cane tissues because we know carbohydrates are positively correlated to freezing tolerance in grapevine tissues and in grapevine buds. So what we did was we took these 2 bud sections, we sectioned an internode from the 2 cane sizes. Then we ground it into a cryomill, and then we further ground it into a powdery consistency, which was then freeze-dried and then extracted and then analyzed using a capillary electrophoresis machine. And then we also looked at anatomical characteristics of these two different cane sizes, normal and large. For anatomical analysis, we used a microtome here to section samples, so we were sure to get a nice, clean, normal cut. And for light microscopy, the samples were stained and analyzed using a dissecting scope. And for electron microscopy, samples were fixed to stop all metabolic activity and then coated in platinum. So let's move into some results comparing these two cane sizes, shoot sizes. And we wanted to see how these two shoot sizes differed in the vineyard. Again, we looked at shoots per vine, and following vine dieback, we found that about 60% of the shoots that came out of the trunk bases after vine dieback were large shoots. And then we looked at the shoot length, and we found that large shoots were about 20% longer than normal shoots. And then we also looked at the pruning weight and found that large canes ended up being roughly 2 times as heavy as the normal canes. And for the lateral shoots, we found that large canes had more total laterals per shoot, and then also more laterals greater than 30 centimeters compared to the normal cane size. And that's something to consider when laterals can play a big part in your canopy management efficiency. So we looked at freezing tolerance of these two cane sizes over a 5-month period from October through March and found interesting differences. So the top left figure describes LT50 of the primary buds of both cane sizes. In red is large and in black is normal. And you can see in November and December, the large cane bud on large canes were damaged at warmer temperatures. So they're less cold hardy than normal canes, primary buds. So the secondary and the tertiary follow a similar type pattern, but what's also interesting is the bottom right figure, which is the phloem LT50. So again, we have large cane phloem in red and normal cane phloem LT50 in black. And you can see in December and in March, large cane phloem was significantly less cold hardy than the normal. So again, we looked at carbohydrates, and although cane carbohydrates, we looked at the whole, we ground the whole cane internode section. So we did not separate phloem or xylem, we ground it all together. We did remove the bark, but we kept the phloem and xylem together, and we found that total and individual sugars were increased from fall, increased to its peak in midwinter in January, and then decreased in the spring. That pattern was found through individual sugars as well. So we investigated cane anatomy by examining internode cross sections. So here's a large cane cross section. It's about 14 millimeters in diameter. And then here's a normal cane cross section. And then this is a zoomed in photo of the above large cane. And we can see the xylem tissue here and then the phloem tissue. And we looked at these xylem vascular transport units, or VTUs. And these are kind of like slices of the pie, so to speak. That's because that's what they look like. And we have the xylem VTU here and the phloem, individual phloem VTU here. And then inside each VTU is a xylem vessel, denoted by the V. And then in here are phloem fibers. You can see these small rectangles in the phloem tissue. Those are phloem fibers. So using ImageJ software, we found large canes had larger xylem and phloem surface area as a general calculation of the entire surface area of the xylem. And then we looked at individual VTUs, and we found, again, similar pattern that large cane xylem VTU and phloem VTUs were larger than those in normal. We expected that. They're larger canes. We expected them to have larger structures. But what was also interesting is that there's a larger number of VTUs. There's more slices of this pie in a large cane than in normal. And that was somewhat interesting and surprising. But we didn't stop there. We looked into each VTU and we counted the number of xylem vessels and then the number of phloem fibers. And again, we found large canes had more xylem vessels per VTU and phloem fibers per VTU than normal. So the take-home message here is that there's larger tissue structures, and also they're more numerous in the large cane compared to the normal. So we can summarize these findings. With vegetative growth, large canes had longer, wider, heavier shoots with longer and more laterals. For anatomy, the large canes were larger and had more numerous vascular structures. And for freezing tolerance, large canes had less cold hardy buds and less cold hardy phloem at certain parts of the dormant season compared to the normal canes. And with that, we can recommend to remove large bull canes and retrain vines using normal sized canes, about 7 to 9 millimeters. So I wanted to offer you guys a break and time to ask questions at this point.
If anyone has questions, please, like I said, use that Q&A feature that you can find on the bottom menu when you move your cursor to the bottom of your screen. We don't have any yet, so maybe give people a few minutes.
Okay.
So Tom, what do you think is the connection between the size of the xylem and phloem vessels and the actual numbers you get for the bud hardiness? Because the buds are isolated from the rest of the vascular system of the canes.
Yes, that's right. It is isolated from the rest of the vascular system. So the logical hypothesis, in my view, would be that with a larger bud from a large cane, it'll have larger structures and more numerous structures in those buds as well. Although we didn't look at that in this study, it's kind of one of the limitations of this study that if I were to do it over again, we would definitely look at that.
Yeah.
However, we could also look at the number of persistent laterals, because as I indicated, as I showed, the large canes had more and longer laterals, and we know that buds that are adjacent to large persistent laterals are less cold hardy.
Okay.
So it may have something to do with actually the physiology of how the large cane grows during the growing season, and having those persistent laterals there as well.
Cool.
Cool. Well, we have a couple questions about bull canes that just came in. So the first one is, Robin wants to know, should we only use bull canes as a last resort?
Yes, I would say only use bull canes as a last resort. Sometimes you don't have the option to not use bull canes. Sometimes those are the only ones you have. So of course I would say retain them if that's all you have. But yes, use bull canes as a last resort.
Okay, and then Horst wants to know please clarify when to remove the bull canes.
You would remove them when you see them in the vineyard, and when you know you have alternative canes to use. You don't want to just remove without having alternative canes to use. Another method is to prune it back and then use the thinner lateral cane shoot that may come from very low on that bull cane. So maybe if you just retain a little bit of that bull cane and then use a lateral shoot from it, you don't have to remove it all the way back down. You can still use components of that cane. But yeah, I would say as soon as you see it and as soon as you know that you have alternative canes to use.
And so that means obviously when it comes time for winter pruning, not say at the end of the summer or when they're still green.
I wouldn't, in this situation, when you're retraining a vine, I wouldn't remove anything in the spring. Again, you want to keep all your shoots that grow after vine dieback. You want to retain as many shoots as possible for many reasons. You want more shoots in case an accident happens with a tractor and it knocks off some shoots, or some shoots get just damaged. And then also you want to retain all your shoots because it then spreads the growth of the vine through all these shoots evenly, so that you're not left with a few vigorous growing shoots. You're left with growth spread among 10 or 15 shoots to produce medium-sized shoots. So you devigorate the vine, and then you're also playing like the insurance game. You still have multiple shoots that will turn into canes the next year that you can select for training.
Gotcha. Okay. And I think with that, we also answered Greg's question, which was very similar, but Greg, please let me know if that didn't answer your question. I think it did though. And then Todd asked, I think this ties in as well, don't you create more bull canes by removing bull canes when rehabbing a vine? So I think you just kind of touched on that, but the issue of, cutting back a lot, and then where does that vigor go, right, when you remove all of them?
Yeah, so in this situation, you can look at the vine dieback as just severe pruning. So the vine was productive the year before vine dieback, and it's been kind of habituated to grow the normal way that it grows throughout the growing season, producing lots of shoots and lots of fruit from the cordon. However, with the vine dieback that we found during the polar vortexes, essentially what we had was someone came through and pruned everything down to the ground. So that's considered, it's pretty much like severe pruning. And when you prune a vine severely, you wake up dormant buds at the trunk base, which then those dormant buds produce shoots, which all of the energy in the roots from the year before goes into those shoots. So essentially what we're dealing with is a severe pruning situation where everything was died back to the ground, and you have to manage those shoots that are growing. So you do, during this vine dieback, you do see a high number of bull canes produced during that process. So yes.
Okay, great. And I think that answered a few other people's questions again. So that's good. But again, people, please let us know if that did not sufficiently answer your question. Eric wants to know if bull canes produce grape yield after being pruned, or is it best to remove those grapes?
Yes, bull canes will produce fruit. However, the bull cane, with its characteristic of long internodes, you can think of those long internode spaces as places where fruit will not occur. So compared to a medium cane, you'll have a smaller internode space so that more clusters will form because there's more buds per given length, compared to a bull cane, which has fewer buds per length, and you'll have reduced yield. You will have yield, but it'll be reduced.
Okay. And then Douglas said, I don't think you answered this, Thomas, but if you use a lateral from a bull cane, will this be more fruitful than the bull cane itself?
Yes, it will. It'll be that way. It'll be more fruitful because there's more fruitful buds per length than compared to a bull cane.
Okay, got it.
Yep.
And that's just because of the smaller internodes.
That's right.
Not necessarily about the fruitfulness of the buds on that lateral, right?
I would say it has more to do with the physical difference in internode length than the fruitful buds.
Okay, I didn't think about it that way. That's interesting. And let's see, I think, do we have... So one more question from Jim. Hi, I took over the vineyard when I came in September. I did not want to cut back as we had a lot of rain and then snow. I need to cut back before bud break, or should I wait till after? We have a double cordon system.
That's a difficult question to answer. I'm not exactly sure what cut back means. I know that you want to do a lot of your cutting back typically before bud break, for the most part, generally speaking. A double cordon system, I'm sorry, I just don't really know how to answer that with the information provided.
That's okay. Jim, if you want to follow up on that, you can send me an email or put something in the chat. And then, oh, Jim says cut back. Winter equals winter prune. He's used to South African vineyard terms. Okay.
Okay. Yeah, so if you're going to winter prune, you're going to want to do that before bud break. You can do it after if you're concerned about a spring frost threat. That's always something to consider. Late pruning allows the more distal buds to break and open up, and then the more basal buds to stay dormant longer. So that's something to consider if you have a spring frost threat that you're worried about. But for the most part, I mean, logistically speaking, you're going to want to get your pruning done earlier than later.
I see. Okay, and one more question, I think, before we move on, and then we'll take more questions at the end. So Alex wants to know if there's any difference in fruit quality, Brix or TA, on the bull canes compared to the normal canes.
That's a good question, and I don't know the answer to that because we didn't look at that per se in this study. We didn't compare fruit from each different cane size. I would say that, just generally, there wouldn't be that much difference. The fruit composition really will depend much more on the way the vine is managed, reducing shading of the cluster, keeping that cluster healthy through the growing season, leaf pulling, shoot positioning, anything that reduces cluster shading. If it's done across a bull cane and a regular cane, you should expect very similar results. I'm not sure though, and that's a good question.
Yeah, that's an interesting question, but my intuitive thought would be that it would depend. It would just be seasonal, just like you treat any other fruit off of a cane. But I haven't researched that either. But that's an interesting question. Okay, so I think that's it for now. Thanks for the questions, folks, and we'll let Thomas continue on.
All right. All right, so let's get into study number 2, which is, I like this study a lot better. It's a lot more practical and interesting in my opinion, and we looked at training systems for trunk renewal. And our hypothesis was that training system impacts vine recovery to pre-damage crop production. And the objectives used to test this hypothesis were to determine work hours to implement each training system, to evaluate vine growth, yield, and fruit quality, and to determine the quality of trunks of each training system. So we collected data in this study, and this included vegetative growth characteristics, yield components, fruit composition, and trunk quality. So this is a diagram that shows the 3 treatments implemented in spring 2015, right after that second vine dieback situation. And on the left, we have the fan train treatment here. We retained all shoots and all clusters from this treatment. These shoots originated from these protected spurs and buds at the trunk base, right above the graft union here. And all we did here was we allowed the vine to grow in a fan shape. It's considered passive training. It's not active training like the bilateral training, or VSP, here, where we trained 4 shoots in the spring and then trained them bilaterally, 2 in each direction. And then we removed any fruit that originated from the trunk base. And then we removed any excess shoots. So we were left with only these 4 shoots. And then the third training system was the fan by VSP. And you can think about it as a combination of these 2 treatments, of these 2 training systems here, where we trained these 4 shoots bilaterally, 2 going in each direction. We removed all the fruit from those 4 shoots, and then we retained all other shoots and trained them into a fan position here. And on these fan trained shoots, we retained all the fruit. So it's a true combination here. So this is Cabernet Franc in early July, before and after initial training. So the left column is fan, the center column is VSP, and the column on the right is fan by VSP. Again, you can see these damaged vine components, these from the previous year damaged canes, and we removed those prior to treatment implementation. And the bottom row shows the first steps in training. So for fan training, we simply used tape-inner tape and wrapped these shoots up to get them off the vineyard floor and to allow them to grow vertically. For the VSP, we retained only 4 shoots. We had 2 going in each direction. We removed any fruit clusters and we removed all excess shoots. So this vine originally had about 15 shoots on it, and we brought that down to 4. And then for the fan by VSP, again, like we just discussed, it was a true combination of these 2 treatments. We have shoots trained bilaterally, and we also have shoots trained in a fan position. And then again, just to repeat, the shoots that were trained bilaterally, we removed fruit from them. So here are those vines at the end of July. Again, we have the fan on the left. We can see this cluster zone developing down here. This is pre-veraison. For VSP, we only have 4 shoots growing. We removed fruit, any fruit that originated here. And then for the fan by VSP, similar to the fan treatment, we have this cluster zone developing. And you can't really see here with this picture, but the architecture of this training system, we have 2 shoots trained to the cordon, and the rest of the shoots were fan trained. So here are those same vines at harvest. Again, with the fan, you have this nice developed fruit zone here. We did come through and we removed shoots, or we removed leaves from this treatment right there at the fruiting wire. Similar, exactly the same as we removed when we cleaned the leaves off of the trunks here on the VSP system here. And then the same goes for the fan by VSP system with this cluster zone here. We cleared out those leaves to allow that fruit to ripen adequately. So this figure, so now we're gonna move into the results, and this figure shows the initial retraining time in spring. On the y-axis is time in hours per acre, and on the x-axis is the 3 training systems. So the VSP system, it takes longer than the other 2 training systems due to the time it takes to select the 4 best shoots, then to remove the excess shoots, and to physically train the 4 shoots bilaterally to the trellis. So the combination training system required about 57 hours per acre, and that's because of the same reasons, and the time is high because of the same reasons as VSP. It's slightly lower than VSP training, however, because we did not spend time removing excess shoots. Remember, on this training system, we retained all the shoots. And then for fan training, again, this is considered a passive training system. And the time is low because no shoot or fruit removal was conducted, and fan training is not active. So we essentially let them grow and position them into a fan shape. So here are the yield components in 2015 of Cabernet Franc and Pinot Gris. There was no treatment effect on the number of, there was a treatment effect on the number of clusters per vine and the yield per vine between fan and VSP. Again, if we remember the fan by VSP, we removed about 4 or 5 clusters from each vine because we removed fruit from the bilaterally trained shoots in this training system. And the fan training, we didn't remove any fruit. So that's why there's that slight difference. So here's the fruit composition. And it's here where we don't see any treatment effects on Brix, pH, or titratable acidity in Cabernet Franc or Pinot Gris. So this means that both treatments in both cultivars were able to mature their fruit at a similar rate. So this slide shows the framework of each training system at the end of the year. And it becomes clear that the fan training here adapts well to really any situation, but especially good for freeze-prone vineyards that implement cane pruning. And conversely, the VSP framework is meant for vineyards that implement spur pruning mainly, because you have this nice, healthy spur material to work with. And then the combination training allows the grower to keep his or her options open because this training can adapt to both cane or spur pruning. So that was year 1, and we're moving to year 2. And just stay with me here. I know this diagram is a lot, but let's just look at the top half of this screen here. We have the fan treatment, which at the beginning of year 2 looked very much like this with these brown canes. The VSP looked very much like this, and the fan by VSP treatment looked like this. And we have the legend up here on the right. Here is pruning cuts, retained canes, and then we have the fruitful buds indicated here. So let's start with fan training. Again, the top of the screen is before converting to VSP, and the bottom is after converting to VSP. So at the top, we have these fan-trained vines, and they were converted to VSP by either retaining 2 or 4 canes, indicated here. So this was fan-trained in year 1, and then cane pruned to 2 trunks and 2 canes, indicated here. And then fan-trained year 1, 4 trunks, 4 canes here. And then VSP was simply spur pruned and maintained on VSP with 4 trunks, 4 canes, and spur pruned. And then fan by VSP was either cane pruned here or spur pruned here. And through all these treatments, we retained a 3-bud spur, and that goes back to spare parts philosophy. You always want to, in cold climate viticulture, it's very important to retain some vine components at the base of the vine in case of a catastrophic winter injury. So that's why we retained 3-bud spurs at the base of the vine. So I'd like to go over this one more time so that the treatments are just very clear. So again, on the left, here's before VSP conversion. This is in year 1. So we have the fan treatment, fan by VSP, and VSP. So for the fan training, we converted it to VSP using 2 trunks and 2 canes, indicated here. And then we also converted it to using cane pruning it to 4 trunks and 4 canes here. For fan by VSP treatment, we cane pruned it to 4 trunks, 4 canes, and also 4 trunks and 4 canes spur pruned here. And for the VSP, we simply spur pruned it and maintained it on VSP in 2016. So we have 1, 2, 3 cane prune treatments, and we have 2 spur prune treatments. And then the photos on the right show the growth progression through the growing season. Okay, so this graph describes the labor requirements in converting FAN, VSP, and the combination training established in 2015 to VSP in 2016. So we have time in minutes per vine as the y-axis, and then we looked at pruning time in green and tying time in the white with the black outline. And then on the x-axis, we have the 5 treatments we just discussed. So FAN training converted to VSP required the shortest amount of pruning time, but also the longest tying time. That's because these 2 treatments did not have the VSP framework, and they required tying. They required that tying to the trellis wire to produce the VSP framework. So FAN by VSP and VSP training in year 1, these 3 treatments required a longer amount of pruning. However, the amount of tying time is almost non-existent for these 3 treatments because the VSP framework was already established. But then you could ask, why do we have any tying time for these treatments at all if the VSP framework was already there? Sorry. And the reason is because 40% of these vines required cordon replacement. And the reason why they required cordon replacement is because of this immense amount of foliage that may have shaded this bilateral cordon zone. This may have shaded the bilaterally trained shoots so much during the growing season that they were unable to acclimate to the cold well enough to survive the winter. You could think about it as the FAN shoots were shading the bilateral shoots. So here are the vegetative characteristics of each treatment. And here's a spoiler alert. It's all about bud number, okay? So we have buds per vine, we have shoots per vine, and we have clusters per vine. And then we're looking at Cabernet Franc, Pinot Gris, and Pinot Noir. And we found that the treatments that were spur pruned had the highest number of buds per vine, which led to the highest number of shoots per vine, and ultimately the highest number of clusters per vine. That was consistent among all 3 cultivars tested. So a similar pattern was found with the spur prune treatments at harvest, because these are the yield components here. We found that the spur prune treatments at harvest had the highest cluster number and therefore the highest yield per vine. And an interesting relationship we found was that the treatments, FAN training and then pruned to 2 trunks and 2 canes, and FAN training trained to 4 trunks and 4 canes, typically had the highest 100 berry weight. So when the yields were decreased, the 100 berry weights increased. You can see the spur prune treatments were consistently lower in terms of 100 berry weight. It's an interesting relationship. So an important parameter to assess vine balance is to determine the leaf area to yield ratio. Previously published work stated that Vitis vinifera is considered balanced when a vine has 0.8 to 1.2 meters squared of leaf area for every kilogram of fruit produced. So values above that range are considered undercropped, and values below that range are considered overcropped, here in red. In Cabernet Franc, all vines had means that extended in, all treatments, had means that extended into this optimum balanced vine range, except for the 2-trunk, 2-cane treatment that was considered undercropped. For Pinot Gris, 2 out of the 3 cane prune treatments were within the optimum range here, and the rest were considered overcropped. And for Pinot Noir, 1 cane prune treatment was undercropped. This one was sort of consistently undercropped among cultivars. And 1 spur prune treatment was overcropped. This one here. The 3 in the middle were considered optimum. So we wanted to double check our work, and similar to the leaf area to yield ratio, we also measured the crop load, which is the yield to pruning weight ratio, which is another easier method to measure the vegetative and reproductive balance of the grapevine. So previous work determined that vinifera grapevines are considered balanced with a crop load within the range of 5 to 10. Crop loads below that range are considered undercropped here, and above that range are considered overcropped. So common among all cultivars, we have Cabernet Franc here, Pinot Gris, Pinot Noir. Common among all cultivars is that vines cane pruned to 4 trunks and 4 canes, outlined in this orange square here, were consistently within that optimum range. So to evaluate trunk quality, we measured the trunk diameter and found that vines trained VSP in 2015 and maintained in 2016 had the largest trunk diameter, which, if we remember to the first study, is undesirable, as larger diameters may indicate reduced freezing tolerance. And again, this was common among all 3 cultivars tested. So this table shows a summary of the 2-year study. And to determine the optimum training system, we evaluated attributes like retraining time, yield, bricks at harvest, 2 different measurements of vine balance, and trunk diameter. We found that fan training, outlined in green here, and cane pruning treatments to be optimum, as they had the lowest total retraining time over the 2-year period, moderate yield, highest bricks at harvest, optimum leaf area to yield ratio, and the smallest trunk diameter. So with that, we can conclude that medium cane size is optimum with increased freezing tolerance. Training systems with high bud number have increased shoot number and yield, but delayed ripening. The fan by VSP training is definitely not recommended in our climate. And the optimum training system and pruning system is to fan train it and cane prune it to 4 trunks and 4 canes. And a practical application to growers would be in year 1 to retain all shoots using the fan system. And then in year 2, when pruning, select the normal cane size and train using 4 trunks and 4 canes. And I'd like to acknowledge my mentors and experts that helped me produce this project, the OSU Viticulture Group, the Ohio Grape Industries Program, and the Ohio State University's Department of Horticulture and Crop Science for their funding support. And with that, I thank you for your time, and I'd be happy to answer any questions.
Great, thank you, Thomas. That was very interesting. So I'll let the questions start up again, and we already have one from Eric. He wanted to know, how many buds per spur do you recommend for VSP? Does it change depending on winter injury?
So typically what's the typical range for buds per spur ranges from 1 to 6 buds per spur, but most vineyards use 2 to 3 buds per spur annually. That's considered normal. If you have 2 large of a spur with too many buds on it, you can get into some non-uniform ripening. You get into sort of a vertical fruit zone because clusters are then stacked on top of each other. So you want to kind of keep it around 2 to 3. And then depending on winter injury, you know, if you have not so severe winter injury that you still have a cordon, you're just missing, you just have damaged buds, you can extend the number of buds per spur so that you can continue to keep your crop. You may want to consider renewing that cordon after that type of injury. So I hope that answers your question.
Yeah, great. And I think, like you were saying, like 6 spurs or 6 buds per spur would be an incredibly dense zone of vegetation as well, right?
Yeah.
I've never seen that personally, so many.
Mm-hmm.
2 to 3 is definitely more commonplace. So Jim wants to know, once the vines have recovered and you enter a normal winter and prune in the spring, do you ever reduce the number of trunks and canes?
So the question, once the vines have recovered and you enter a normal winter and prune in the spring, do you ever reduce the number of trunks and canes? Well, whenever you reduce the number of trunks, you're reducing your insurance. So you can consider spare parts, spare trunks as a way to ensure that no matter what, you have at least components of the vine that you can build from. So sure, I would say you could remove trunks, but I wouldn't remove them completely. I would keep spurs at the base. I would keep portions, maybe a 6-inch portion from the ground of that trunk, because even though it doesn't look like it, it probably does have some buried buds down there. In the case that we do get hit with another polar vortex, you'd want that insurance.
Okay, great. And Horst wants to know, please explain again why you recommended fan training when your best performing system in year 2 was VSP spur pruned.
I would answer that by going back to my slide here and saying that it isn't the best performing. It has the highest yield in year 2, but it's not the best performing because the vines, those VSP trained spur prune vines, were considered not balanced, and they had, at the end of this 2-year study, they had the largest trunk diameter. It was more difficult to ripen those grapes because they had lower bricks at harvest. And that's something to consider in Ohio and Michigan and New York when sometimes we have short and variable growing seasons. So I looked at it from a summary of both years, which training systems are best over the retraining process.
Okay, great. I hope that answers your question first. And now Charlie's asking, and you might have to clarify this, Charlie, because I'm not entirely sure of the question, but maybe Thomas understands it better. He said, I have a lot of growth in the spring with many buds. Is there a time to remove buds so that we can reduce the bud growth?
I'm not sure on what that question is asking. I have a lot of growth in the spring with many buds. Is there time to remove buds? I'd ask Charlie to please try and be a little bit more specific because I don't understand the crux of the question. So I'm sorry I can't answer that, but if he asks it in a different way, I'd be happy to.
Yeah, so get back to us on that one, Charlie.
Yeah. If I can jump in,
Yep.
I'm thinking that maybe what he's saying is that with the amount of buds he leaves, he has far too many shoots. So that might indicate that you should consider doing some shoot thinning when pretty early in the spring to get your appropriate shoot density, because the thing that matters in the end is how many shoots per foot or meter of vine you have, and not necessarily how many buds you leave, but but it's possible that you're leaving too many buds at pruning time, and then also that you're just getting too many shoots emerge, and then I think doing some shoot thinning would be indicated.
Yep. Yeah, I agree with that completely. Thank you.
Okay, we've got still a bunch more questions. So Greg wants to know, in regions with large amount of snowfall, when can we safely start pruning without causing injury to the plant? If we have a mechanical pre-pruner, can we pre-prune in late November or early December and then do follow-up detailed pruning over the remainder of the winter? We cannot wait until snow melts to use mechanical pre-pruners to rough out, as not enough time to finish final pruning before buds swell.
Okay, so that's a difficult situation. You know, you're kind of pinned. Time really isn't on your side there. So, you know, when you pre-prune, I assume you're leaving many more buds than you're going to keep for the next year. So I would say pre-pruning, unless the snow is you know, covering the entire vine, I don't see snow really playing a factor in the buds that come off of the cordon. However, if it does, then that's great. But I would say that you know, we can't wait until snow melts to use mechanical pruner to rough out. It's not enough time. You know, this is kind of this has to do more with logistics of vineyard operations, and you know, you're not going to harm the plant by pre-pruning per se. What you're doing when you pre-prune is you're limiting how far you can delay bud break of the basal buds. So when you pre-prune, you're essentially you can stimulate bud break in the lower buds compared to not pre-pruning because of the apical dominance of the vine. Buds towards the end of the cane open up earlier than the buds at the basal end. So I would say, you know, you're probably safe doing that, but I would wait as long as I could to prune, just because the memory of these you know, these winters are still fresh. So I would wait as long as I can, while also giving you enough time in the beginning of the season before spring to prune. So I hope that answers your question. If you have another follow-up one to that, a little more specific, I'd be happy to answer too. Okay, so just to reiterate, Thomas, so no harm in pre-pruning early, right? That's the takeaway there? Yeah, I mean, if we're into the dormant season, November, December, when you cut into the plant, there's probably not that many diseases or fungal, viral diseases that are gonna get into the vine at that time, you know, compared to spring and early summer. So I would say you're probably not gonna harm the plant per se right there. What you do is you're reducing your ability to delay bud break if you're in a spring threat area. So with that being said, you know, always wait to prune your hardy or your least hardy varieties last, your most hardy varieties first. And, you know, whatever logistics works for him, I think he should keep doing that. Okay, and then Elliot wants to know, should this information make us consider switching from VSP spur training to cane pruning? And he followed that up with, before winter injury ever occurs, that is. You know, this has a lot more to do with the susceptibility to winter injury in your location. For example, in Michigan, vineyards, we can safely expect 1 to 2 severe winters in a 10-year period. So that would cause growers to probably want to do cane pruning, because it doesn't have as many above ground vine components as spur pruning does that are susceptible to winter injury. So the answer is, if you experience severe winter injury more than 1 or 2 times every 10 years on average, then I would say logistically you may want to consider cane pruning because of the ease of replacement. You're not, you're not putting time and labor into developing the spurs. That being said, after you kind of recover the vine, there's no problem with starting your vines to become spur pruned vines. There's nothing inherently incorrect about that. That's your choice, and if that makes sense for you and your viticulture, I would say go for it. This is just simply during the retraining process to set you up in the future.
Got it.
Yep.
Okay, there's a lot more questions, but unfortunately we're going to have to do a follow-up answer to those questions via email because we are out of time. But I thank you all for your enthusiasm, and before I let you go, I just want to just let you know of a few closing notes. So if everyone can see my screen, I think. Nope, not yet. Sorry, so there we go. So we have to thank our sponsors again for their support with continuing this webinar series. And lastly, I wanted to just notify you all of our other webinar series that's starting on Thursday for the VitusGen project, which I mentioned last time. And we're really excited about this. I think it's going to be a great webinar series. We're talking about Europe embracing hybrid varieties. So that's a political question too. And we hope you'll join us. There's another one coming up in April. And if you're interested and you're not already on the list, please let me know and I can add you to the list. And thank you, Thomas, so much. This was a great, very informative webinar.
Thank you for the invitation and happy to come back next time.
Yeah.
So Raquel?
Great. Yeah.
When's the next Northern Grapes webinar? That's going to be...
Yes, the next Northern Grapes webinar is on April 10th with Tim Weigel, Dan Olmsted, and it's implementing the NUA weather and pest model information into a vineyard IPM strategy. And I will send out a registration email for that early next month.
Yes, and I want to mention here that NUA has been really successful at expanding throughout the Midwest, and we have a lot of disease management models and insect management models that are on NUA that are accessible to people with weather stations in Iowa, in Wisconsin, and in Michigan in particular.